Hello, welcome to this module on data engineering. This is your instructor Kumaran here. Data engineering is a vital part of data science, and it is the most difficult part of data science. Getting data from its sources, making sure that the data is valid and reliable, and cleansing them and doing its transformations and putting it into a repository where it can be properly analyzed is one of the most painful tasks that you do in data engineering. It is the most painful, most laborious, most time consuming, and this is what will give you headaches in your data engineering life, or sorry, your data science life. So let's start with trying to look at what kind of data sources exist, or what kind of data sources a data scientist will deal with. The data sources play a very important role in determining what kind of data processing you do. The type of the data, the source of the data determines what kind of data processing you do and what kind of data processing architecture and workflows you would set up. And this is depending upon what kind of data quality and reliability exists for the source data. Is the source data really reliable? It can be believed, or you have to do a lot of checks and measures and validations to make sure the data is indeed reliable. It also impacts your network planning, because the size of the data and where the data exists and the bandwidth required to move the data from one place to another, they all would impact your network planning considerations. You might have to put in some fault tolerance capabilities if the data is flowing through an really risky network, or that the data is coming in real time and you cannot go and reprocess the data. So you have to set up fault tolerant capabilities. Security is an important consideration. Typically, a lot of security measures are put in place, especially if the data is flowing across organizations or the data is coming from the clouds. There are also organizational boundaries to deal with, because you might be sitting in one department and then the data will be sitting in another department, and you have to work through the organizational boundaries in order to get access to the data and get the data into your domain to start working on it. What kind of data sources are there? The first kind of data source is the enterprise data sources, where the data sources actually exist within your company or organization. This is the easiest data store, or the most convenient data store that you might have, and this typically is an RDBMS. Enterprise data sources are generally CRM systems or any kind of systems, and typically they are sitting there in RDBMS. They are typically populated by some good applications, well-built applications. Why I mean them as well-built applications is that the applications typically take care of validating data. When the user is entering data, the UI usually validates and makes sure that the data being entered follows certain rules and constraints. Like, okay, the data allows a few characters. You can only do a pick list of values. Some columns are mandatory. It makes all these checks and make sure the data that is coming in is complete. Even things like foreign keys are usually completely linked with the foreign key table. So it is pretty complete and pretty clean. Accessibility to the enterprise data sources is easy. There are no rate limits. If you are looking at cloud data sources, there are rate limits in terms of how much data you can access in a given day or in a given 15-minute window. Organizational data sources do not have these rate limits. That's an advantage for you to design the data flows, or how you can extract data from these sources. It has excellent quality and reliability. There won't be any errors or missing records or missing fields typically in an enterprise data source. But the issues are that the data guardians, you may be getting data from another department, or you're getting from data from IT, and you have to answer a number of questions as to why do you want this data, how are you going to be using this data, because they have to make sure that the data is not misused in any way, or the security of the data is not compromised in any way. So you have to go through these organizational boundaries. You have to go through these organizational boundaries to get across the data guardians and get the data flowing. But enterprise data sources are one of the cleanest and cleanest data sources that you can get. The second type of data source today, which is getting more and more popular today, are cloud data sources. A number of organizations are moving their applications onto the web. So obviously, rather than having enterprise application, you have cloud-based applications, and the data is sitting in the cloud. And how do I go get data from the cloud is a big challenge. So data is hosted on the web. Like Salesforce is one of the most popular cloud application centers, and it has today a number of companies are using Salesforce for their sales activities. Access of data in Salesforce is typically through SOAP or REST APIs. A lot of companies do support CSV downloads, but CSV downloads are a pain and not that much of a security, especially when you have to program something. SOAP and REST APIs are far more secure, far more reliable and robust, and the new age cloud-based data sources are usually support SOAP and REST APIs. Security in these cases is a predominant factor because you're getting data from the cloud and the data is flowing through the public internet. So you have to make sure that the data exchange happens without any kind of security compromise. Rate limits may apply, and there is limits usually which these vendors put in as to how much of data can you extract in a given day. And that is also determined by the kind of licensing you have or the kind of product you bought. So you have to consider that also when you're building your data acquisition code as to how much data you can get, how frequently you can get, and stuff like that. Quality of data will typically still be excellent because the cloud data sources also put in constraints and checks and balances to make sure that the data is how it should be, and it makes sure that the data is actually like that, like what are the valid values, or what are the columns that cannot be empty and can be empty, and any kind of cross-linking like foreign key linking are all taken care. So the quality of data is also pretty much good. Then third type of data is social media data sources, where you're trying to get data from any of these social media websites like Facebook or Twitter or LinkedIn or Google. Today, there is a lot of data mining going on these kind of data sources because you want to mine information about people, and then you try to analyze them. Maybe they are your customer, they may be your potential customers. You mine data about them, you want to analyze them, and then use this analysis for further research. They are similar to cloud data sources in most aspects. Like they have their own REST APIs and security. They have rate limits, all this stuff. But the thing is, accessing public data about people and companies might involve privacy issues. So that is the only thing you want to consider as to what kind of data you can really extract and use about other people without telling them. Rate limits in these cases are pretty restrictive because you're not paying for them. These are all free services. So they typically limit how much you can get, how much of data you can get in and get out. So you have to consider this before you build all your data extraction programs. Data is mostly profile based and transaction based in these cases. So you're basically getting data about people and finding all their links or building their network and stuff like that. The last way is the brute force way, which is called the web scraping way, in which case you're just scraping website in a very raw way. You're just getting the entire HTML of a website, and then using that HTML to extract pieces of information inside the HTML and then trying to use it. This is a very cumbersome way because the HTML code can be like anything. It has so much things embedded like JavaScripts inside and stuff like that. So you really have to build a really intelligent code to kind of do this web scraping. And in web scraping, you are pretty much looking inside the HTML you extracted for other links, and then you go to those other links and continue to keep extracting data. A very hard way, a very cumbersome way of getting data. And data is very dirty because there is no reliability, or there is no guarantee that the data is going to be of this kind of a shape, or make sure that all the columns you need or the data elements you need always exists. Now there is no guarantee for these kind of things. So you have to pretty much do a lot of cross-checking and balancing, and in fact a lot of data imputations if you want to get data from web scraping. And this is mostly text and require a lot of significant processing resources, because for using these data for predictive analytics purposes, you have to convert text data into numbers data, and we are going to be seeing later in this data engineering section as to how you can do that. There's a lot of security, privacy, and intellectual property concerns, because you just brute force web scraping without telling the owner of all the stuff that you're going to be doing that. So you have to be aware of what you can really get, what you can really scrap without impacting into the security, privacy, and intellectual property concerns of the owners of the web pages. So what kind of data formats is the data flowing in today? You can have tables that come from RDBMS, that is the most famous and popular structure, very structured data that is coming in. You have data in CSVs. This is the most common data exchange formats. Typically when somebody asks your data, this is the easiest data that you can extract and send, or the easiest data format that you can receive. CSVs can hold large amount of data, but their processing is a lot of manual moving around of these CSV files from the source and the destination will happen. XML is used for configuration and metadata, but it sometimes can also hold the actual data that you want to use. It depends upon the source of the data and what kind of formats the source supports. JSON is the new age exchange format that is becoming very popular. A lot of the applications today support JSON. In fact, all the cloud data sources today, like even Salesforce or Twitter, they support JSON. So JSON is the most popular new age data exchange format in which data is flowing across the web. Raw text, of course, is the last resort. When you have raw text, you typically have a lot of processing to do in terms of getting the text and processing the text and cleaning it out and then getting the information you want from the text. And the last format is binary, like images and voice streams. If you are trying to analyze images and voice stream, that is another type of data that you want to be extracting and moving around. This data is like huge. The size of this data is typically huge. As we know, images and voice streams take a lot of space, so you have to take into consideration all those requirements, like the storage requirements and the bandwidth requirements, to get this data and move this data around. Moving on to the data acquisition, what kind of trends are today happening in terms of how do you acquire data from the source? To acquire data from the source, typically they can be like in batch mode. That is the most popular mode, where you get a data file every day from the source to the destination, typically a CSV file, and then you start processing the CSV file on a daily basis. But today data acquisition is getting more real time, in fact really real time, where you typically set up push triggers on the source, so that anytime there is a new data coming in and data are modified, you typically immediately get an event from the source to the destination, and then you have to get it and immediately process it. So real-time analytics or streaming analytics is becoming more and more popular today, because people want to have information and analytics in real time. So data acquisition also becomes real time in those cases where data acquisition has to happen through these push triggers. Interval acquisition happens like every 30 minutes or so. It is kind of a balance between the batch and real time. So where sometimes real time triggers are not possible, if the source is not supporting push technology, then you have to have an interval based acquisition, where you go there every 5 minutes or 10 minutes, look for all the records that have changed and pull all the records. And then you can actually create a hybrid system of batch, real time, and interval, where you can maybe say some data comes in real time, some data comes in interval, and some data comes in the batch at the end of the day. Or you may get the same data again in batch end of the day to make sure it is complete. So all kinds of data acquisition strategies are today deployed in the world for moving data from the source to the place where analytics happens. So what determines these acquisition intervals are the analytics needs. How frequently do people need this analytics? Then availability, is the data really available in real time? Is it only available end of the day? Then rate limits, how much data can you get in a given day or in a given time frame? That determines how much data you can acquire, whether you want to do interval acquisition or real-time acquisition. And finally, the reliability of these channels. How reliable are real-time channels versus the batch channels in terms of security, in availability, and making sure that the data comes in one piece from the source to the destination. So all of these determine how you come up with an acquisition strategy for the data. Data acquisition, when it comes to data acquisition, the coding part or the programming part is not the challenge. I mean, you are already, if you are programmers, they usually know how to get data from one place to another, and these applications are typically built as web applications or Java J2EE applications or Python applications that move data from one place to another, industrial quality applications. The challenge is more the non-technical part of getting data, working through all these limitations, all these challenges, and making sure that you have a data acquisition architecture, a workflow that takes care of a lot of these issues and considerations. Thank you.